Today we will talk about vectors in the context of how we use them to understand some of the measures in physics. So let's get to it. To understand vectors, let's look at something very simple, something as simple as a particle moving in a straight line. So this is a straight line that we have, this is our 0 point. A particle can move into this direction or it can move into this direction. Normally we would say that if it moved in this direction we call it positive and this direction we call it negative. So this would, let's say this is 5 meters, so this will be plus 5 meters and this would be minus 5 meters. Now to understand a quantity like this or a measure like this, we don't, only sign is enough. We can tell the magnitude, which is 5 in this particular case, and we can tell the sign, which will tell us whether we went to the right or to the left. But unfortunately there are only there are many measures in study of physics which actually do not restrict themselves to just 2 dimensions, 1 dimension, not even a question of 2 dimensions. Sign can be used to only signify those quantities or measures which are just in 1 dimension, like this line. As soon as you enter 2 dimensions, the life gets complicated. Let's look at something that is in 2 dimension. Let's draw a square or a rectangular field. Let's say this is our rectangular field. Let's say this is our rectangular field, and now in this rectangular field, let's say we have a person here, let's say this is the person and he is at this particular location. This person can go in this direction, he can go in this direction, he can go in this direction, he can go backwards. Now this person can go into any of these directions, and suddenly you realize that just a sign is not enough. You cannot just tell a sign and clearly say where did he go. Of course there is the magnitude, for example distance from here to here, let's say this is 2 meters. So this is let's say 2.5 meter. So we can tell distance, but when we say 2.5 meter, it could be along this line or it could be along this line. So suddenly we realize it's not sufficient just to have a sign to explain our quantities, and that's where the whole concept of vectors come in. So what is a vector? Vector is basically nothing but a measure or a quantity that has a magnitude as well as direction. Now what does that really mean? Let's assume we are talking about a 2-dimensional space. So let's say we have something like this. This is our y-axis, and let's say this is our x-axis, and let's say in this we have a object that is lying here and it moved in this direction to here. Now if you want to explain this particular quantity, a simple way to explain would be to find out the distance or displacement or the magnitude, which is, let's say it is 5 meters. So we say 5 meters, but this is not sufficient. We also have to tell the direction, and one simple way of telling direction would be to measure the angle from some axis, and for simplicity's sake we can say we will measure the angle from x axis. So, if we kind of extend this backwards to we can measure the angle from x axis in two ways. Either we draw a line which is parallel to x axis but passes through this line, and we can use that, and this is our axis essentially. This will become our angle, which is theta. So, now we can see, we can clearly explain this particular quantity by the distance and theta. So, we can say this displacement was 5 meters at an angle of theta from x axis. Now, this is nothing but a vector for us. This is how we define a vector. So, a vector is nothing but a magnitude and a direction that specifies a physical quantity. So, we need to have two things, a magnitude and a direction. Now, we have to keep in mind that vectors make sense only when quantity is represented in more than one dimensions. If it is just one dimension, your angle is not going to be there, so you can represent that with just a sign like we do with the time. So, now let us understand, this is a vector. Now, let us look at a very simple quantity which is represented using vectors, is called displacement. So, displacement, some entity was at this point and it ended up being here. What is the displacement? Displacement is nothing but this is displacement d. Now, as we have already talked about, we can explain it with d, which is the magnitude, and theta, which is essentially the angle with the x axis. Displacement has another very interesting property. Displacement only measures the starting point and the ending point. It does not measure the journey that has happened. So, for example, if this point went this way versus another point went this way versus another point went this way, the displacement for all of them is same because their starting and ending points are same. So, if we look at a displacement vector like that, let us look at a few displacement vectors. Let us say we have couple of displacement vectors where let us say there is a object at this point. From point A, this object traveled to point B, and from point B, this object traveled to point C. Now, this travel could have happened any which way. This guy could have gone all the way here and then here, or this guy could have gone here and then came back here. As far as displacement is concerned, displacement is nothing but the distance between the start and end points. So, for us, the displacement vector is going to look like this. This is our displacement vector between A and B. Similarly, from B, the point could start and go like this, or it could go like this. That does not matter. What we are really worried about is the start and end point, and as far as the start and end point is concerned, this is going to be our displacement vector. Now, let us say somebody started from point A, went to the point B, and then went to the point C, and now we want to find out the displacement. And we know that displacement is path independent. It does not matter which direction we took. So, what we really want to find out, what is the total displacement between A and C. So, let us say our vector A was this, and this is our vector B. What we really want to find out is addition of vector A and addition of vector C. Let us say this is equal to S. There is a third vector called S, which is equal to addition of vector A and B. So there is a geometric way of finding this. Basically what we need to do is to have our vectors drawn head to tail, which is in this case the head of vector A is joined to the tail of vector B, so that they are drawn head to tail. And once we do that, we can find out the addition of these vectors just by completing the triangle, and that will be our resultant vector. So basically if we want to complete this triangle A, B and C, so we basically draw a line from A to C, and let's see, let me just get this right, yeah, here, and we add this join, and if you see, so the addition of vector A and B is nothing but vector S. S is equal to A plus B, and this is basically the addition of two vectors. Now let us say there is another interesting thing. Just now I said that vectors need to be drawn head to tail. Let us say the vector was not head to tail. We know that a vector can be represented only by the magnitude and by the angle. So let us say if this was our vector, let us say this is our vector B. If we draw another vector that is parallel to B and which has the same magnitude as B, this vector will be identical to the vector B. So basically we can always draw a vector of the same magnitude which is parallel to another vector, and it will be equivalent to the other vector. Why do we need to do that? We need to do that because if you really see, there is this interesting thing that we want to do. For example, rather than adding A plus B, let us say we wanted to add B plus A. Now we cannot do B plus A because when we do B plus A, the head of B is not connected to the tail of A. So what we can do is we can draw a vector parallel to B, which is, let us take this and let us move it here, and we can draw a vector here, and similarly we draw another vector parallel to A, so now if you see, now if you see, we have this other vector which is parallel to B. This is also equal to B because the magnitudes are same and the angles are same, and it does not matter where does it start from. Similarly, this is also a vector equal to A because the angles are same and the magnitudes are same. So now if you see, if you wanted to add B plus A, the head of vector B is connected to the tail of the vector A. So we can say B plus A, which is, if we want to do B plus A, we can look at this. This is basically B and this is A. So we can say B plus A. And what is it equal to? What is it equal to? It is equal to nothing but S again, because if you take B, A, it is equal to vector S. So here we prove the first law, which is if we are adding two vectors, addition of vector A plus B is equal to addition of vector B plus A. This is, you would remember from the arithmetic and the algebra, nothing but commutative law. Commutative law of vector addition is nothing but a plus b is equal to b plus a. Now that we understand commutative law, let's move on to the next thing. Rather than 2 vectors, let's start with 3 vectors now. Let's start with first vector as this, then we take the second vector, let's say this is this, and let's take a third vector that looks like this. So we have 3 vectors now. This is A, this is the arrow here, this is B, this is the arrow here, and this is C. Now let's say we want to add these vectors. Now we can first add A plus B and then add C to it. So the addition of A plus B will be this guy. So this is nothing but A plus B. Let's do in another color. Let's take green. So this is A plus B. So this becomes A plus B. Now we want to add A plus B to C. So see, they are head to tail again, A plus B and C. So this vector will become here, and let's say we add them. So this becomes A plus B plus C. But now let's say we want to do it other way around. We want to first add B plus C. So let's take this B plus C. Vector B and C are head to tail already. So let's add them. So this becomes B plus C. Now we take B plus C and we will add. So this is our A. A and B plus C are head to tail. So we can add them, and that is nothing but this guy again. So this becomes A plus B plus C. So what we have proved? We have proved that A plus B plus C is equal to A plus B plus C. This is nothing but, again you would remember from the arithmetic and algebra, this is associative law. So this is the second law of vector addition. Now let's look at the third thing, is that how do we subtract vectors? So we have added the vectors. Now we want to subtract. So let's say we have 2 vectors. We have our A, and let's say we have our B. Let's say this is A and this is B. Let me draw in another color. Now this is B and this is A. Now as we know, if you are adding 2 numbers, which is if you want to subtract 2 numbers A minus B, what you can really do is you can do A plus minus of B. So we are going to use the same trick essentially. What we are going to do is we will draw another vector which is perpendicular to B but facing in opposite direction. So let's take another vector, and we also know this thing had to be head and tail. So, if right now the head of B is downward, it will eventually become upward. So, if we take a vector parallel to B, but draw it at the head of A, that will essentially become head to tail. So, now this is what we draw B, but it is pointing in opposite direction. And of course, the magnitudes have to be same. So, now because this is pointing in opposite direction, this vector becomes minus B. Now, we can add A and minus B, and that will essentially tell us what is the value of A minus B, which is essentially this vector. So, the point here is very simple. Whenever you have to subtract vectors, you take the second vector, convert it to negative by changing its direction, and then you can basically find out your the value of A minus B. Now, similar to algebra, you can also do arithmetic, which basically you can do similar rearrangement of equations. So, if you have an equation like vector A is equal to vector B plus vector C, you can write that vector A minus vector B is equal to vector C. It basically means the same thing, and you can clearly look at it. For example, if we were to look at this previous example, where we had, rather than B being minus, if we were to draw it on the other side and change the direction. So, if we were to make it like this, we draw a line parallel to minus B, and because we have to keep it head to tail, we essentially draw it from here, and we have to do it like this. This will become plus B. And if we were to move this to A minus B, for example, if we were to move this vector which we have, but essentially draw it where the A minus B's head is. So, for example, let us take A minus B. For the sake of simplicity, we move it here. So, let us say this is our A minus B. Now, we take the vector plus B, which is this one. So, let us say we take our vector plus B. And we bring it here, and let us say this was our plus B. If we add A minus B and plus B, that will be nothing but B, I mean A, sorry, that will be nothing but A. So, that will be this vector. If you look at our previous picture, that was our A vector, the blue vector, which is this one. So, basically, all the subtraction addition rules that we have seen in arithmetic would apply to this. Now, as we can see, geometrically, the geometric method of adding vectors and subtracting them is easy if you have smaller numbers of less complicated vectors. But as soon as you get into complicated vector arithmetic, this method is going to be very, very impractical. So, there is another method which is actually a more mathematical method, that requires us to find what are called components of the vector. Now, what are components of the vector? Components of vector are nothing but whichever space you are operating in. If you are operating right now, for example, we are talking about two dimensional vectors. So, you have a x axis, and let us say this is your x axis and this is your y axis. So, sorry, this is x axis and this is y axis, and let us say we have a vector which is this one. Let us do it a nice 30-degree vector. Let us say this is our vector. Let us do another color. Let us say red is our vector, this is our vector, and what we need to do is we need to find its components. And how do we find the components? You basically project the vector on respective axes. How do you project a vector? You draw a perpendicular line from that axis that touches the two endpoints of the vector. So, for example, if we were to find the x axis projection of this vector, we will draw lines perpendicular to x axis. Let us take a slightly thinner line. Let us take this, let us make it 90 degrees. So, this is one projection. Now, we go to the other side. This is another projection. Now, we do y axis projection. So, we set it to 0. So, this is one end, this is another end, and now if you can see, these are nothing but, we can call it, let us say the vector was A. So, this will be the magnitude A. So, this will become Ax, which is the x axis component, and this will become Ay, that is the y axis component. Now, how do we find the values of this? Again, let us go back to our 10th standard trigonometry. We know that the angle of vector is theta. So, this is our x axis we drew, and this is our y axis. We do not need y axis, let us leave it. So, our angle, this is the angle theta, and we remember, and if this is Ax, this is also Ax, this line basically this particular line, let me draw it in green color. This is also Ax. So, now from our trigonometry we know that base upon hypotenuse is cos theta. So, we can write Ax upon A is equal to cos theta. So, Ax is nothing but A cos theta. Similarly, we know perpendicular upon hypotenuse is sin theta. So, we can say Ay upon A is equal to sin theta. So, Ay is equal to A sin theta. So, these are our two components. So, we can now what we can say, Ax is equal to A cos theta, and here theta is the angle with x axis, and Ay is equal to A sin theta. So, this is what we have for the two components of the vector, and of course, we have the angle which will essentially tell us the direction. Now, let us say we are given the components of the vector and we have to find magnitude. We can see very clearly from these two, if we square both sides and add them, then what will we get? We will get ax square plus ay square is equal to a square cos square theta plus a square sin square theta. We can take a square common, so we get ax square plus ay square is equal to a square cos square theta plus sin square theta. This is 1, so we get ax square plus ay square is equal to a square. So a is nothing but square root of ax square plus ay square. So this is another property which is nice to remember. Given the components of a vector, if you wanted to find its magnitude, you can find it. Now the only thing that is left in this series is, if we were given the components of the vector, how do we find the angle theta? We can very clearly see one has cos theta, other has sin theta, or even just go to basic trigonometry. What is tan theta? Tan theta is perpendicular upon base, so which is nothing but ay upon ax, which you can get from this also. If you divide the second equation from the first equation, you will basically get a sin theta upon a cos theta is equal to ay upon ax. So tan theta is equal to ay upon ax, and theta is equal to tan inverse ay upon ax. So these are basically, this is the last of the bits that you probably need to remember, and it will be helpful. Now the question would come, why the hell are we doing all this? What is the point of it? The point of it is very simple. Let's go back to our previous situation where we had two vectors. So let's say, let's draw our axis first. So let's say this is our x-axis and this is our y-axis. And let's say we draw two vectors. Let's say there is one vector which is let's take like this. Let's say this is one vector, and let's say there is another vector which is like this, and we are drawing them head to tail just for simplification reasons, so that understanding is easy. So this is the other one. So basically what we have is, this is vector b, so this is our vector b, and this is our vector a. Now from whatever we have learned, what will be their addition? Their addition will be vector c, which will be this guy. So this will be our addition vector c. So now what we are saying is c is equal to a plus b. Now what we are really saying is that if we wanted to add these two vectors mathematically, what we can do is we can find their components. So what will be their components? The component of the first vector would be this guy. So this is the x component of the first vector, and this is the second guy, and this is the third guy. So these are two components. So this is basically ax, this is bx, and similarly we want to find these two components. So this is the first component and this is the second component, and this is the third projection basically. So now if you see, if you look at the angles, the angle of A is negative, so its y projection would actually be negative. So basically what we are saying is, here what we are saying is that this is Ay and this is By, and the Cy is nothing but By minus Ay, because their angles are different, and because of that they will have to be subtracted and not added. So your resultant vector, if you really see, this is your resultant vector and its x projection is nothing but Ax plus Bx, and the y projection is nothing but By minus Ay, and that is basically for a simple reason that the Ay is negative, because the angle is, if you believe this to be x axis, this angle is minus theta. This will be clear if we do another one where A was, let us say we do another one where both the angles were positive. You will very clearly see. Let me quickly do this. So let us say this is my A and then this is my B, this is Ax, this is Bx, this is Ay and this is By. So now if you see, the resultant vector is this, which is C, and the y projection of C is Ay plus By, and the x projection of C is Ax plus Bx. So what we are saying is that if we want to add or subtract vectors, if we break them down into their components, we can just add components, and those components, addition of those components would give us the resultant vector. So as we know now, a vector A can be given as Ax cos A cos theta, which is its x component, and A sin theta. This is our vector A. And if we have another vector B, which is B cos theta plus B sin theta, we can just do addition of vector A plus B as nothing but A plus B cos theta plus A minus B plus A plus B sin theta. Now in this case we are assuming the theta is same, the angle of both the vectors are same. But if they are different, let's say B was B cos alpha plus B sin alpha, then A plus B will be nothing but A cos theta plus B cos alpha plus A sin theta plus B sin alpha. So that is why being able to find components is very important, because in a complicated mathematical discussion we would need to really break them down into their components and solve these vectors. Let us look at a small numerical problem basically what it says is that we have a magnitude, basically what we have said is that a plane leaves an airport and it is sighted 215 kilometers away. So let's draw our axis. Let's say this is our x-axis. Let's do them black. This is our x-axis and this is our y-axis. Now what we are saying is that the plane was sighted somewhere here, and this is our plane, and this distance is 215 kilometers away. So this is nothing but 215 kilometers. Now what is also given is that the direction of the angle is 22 degree north. So basically what it really means is, if you have north, this is our north, direction from north, it's saying the direction was 22 degree east of north. So this is north, east is in this direction, it means the direction is this. So basically what we are saying is, in our case, the angle from y-axis is 22 degrees. So it means the angle from x-axis is 68 degrees. So now basically what it wants us to find, that how far east and how far north is the plane. Now it is easy. If you see, how far east is nothing but how much it has traveled on x-axis. So that is nothing but 215 cos of 68 degrees, and how much north it has traveled is nothing but 215 sine of 68 degrees. So which is nothing but, this comes out to around 81 kilometer, and this comes out to around 200 something kilometers. So this is like one simple question that you might be asked, which requires you to break them down. Now when we are doing these kind of questions, sometimes you might be given angles in radians and degrees. So we need to understand what is the relationship between degrees and radians, and it is very simple thing. If you look at a circle is 360 degrees and it is also 2 pi radian. So basically you can just believe that 2 pi radian is equal to 360 degrees. So 1 radian is equal to 360 upon 2 pi degrees, and similarly 1 degree is equal to 2 pi upon 360 radians. So you might require this for sometimes computation and things like that. So I think this is we have kind of finished the basics of what the vectors are, and we have done everything in 2 dimensions, and I think I will stop this video here because it's long enough, and then we will in the next video we will try to cover the full vectors with 3 dimension vector algebra. So if you have liked this video, please subscribe to the channel and hit the like button, share it with your friends, and if you want to see videos on any other topic, please let us know, and we will try to put a video on that particular topic. With that, I am going to end this video for today, and have a good day. Have fun.